Suppose a plus b plus c equals to pi radians, then we need to show that sine of 2a minus sine of 2b plus sine of 2c equals to 4 times the product of cosine of angle A, sine of angle B and cosine of angle C. Okay, let us begin. Now this is a problem of conditional trigonometry, because if we consider the identity sine squared theta plus cosine squared theta, that's going to be equals to 1 for all values of theta. That means any values of theta that we choose, this is always going to be a true case, meaning it's an identity. But for our case, sine 2a minus sine 2b plus sine 2c, this is going to be equals to 4 times the product of these three trig functions under the condition that the sum of the angles a, b and c must add up to pi radians. That's why it's referred to as a conditional trig identity. Okay, so what we'll do, we'll start the problem from the left hand side. And here on the left hand side we have sine of 2a minus sine of 2b plus sine of 2c. But what we'll do, we're going to first consider sine of 2a and then we're going to add it to sine of 2c. So there's a standard formula for adding to trig function. So we're going to add these two trig functions together and then we're going to leave the second term as it is, negative sine 2b. Now sine 2a added to sine 2c, here we're going to use the fact that if we have sine of angle C added to sine of angle D, then this is going to be simply 2 times sine of C plus D over 2 multiplied to cosine of the angle C minus D over 2. So for our case, we will suppose 2a to be is equivalent to C and 2c to be equivalent to D. Therefore, we now have 2 times sine of the angle. So 2a added to 2c divided by 2, that's going to give us a plus c, multiplied to cosine of, we need to take the difference of the two angles, 2a minus 2c, and dividing by 2 gives us a minus c, minus we have sine of angle 2b. Fine. Now here we're going to use the condition that a plus b plus c equals to pi. So since a plus b plus c equals to pi radians, so what we can do, we can keep a and c on the left hand side and transpose b to the right hand side to get pi minus b. Now here we have sine of a plus c. So what we'll do, we're going to take the sine function on both sides to get sine of a plus c, and this is going to be equals to sine of the angle pi minus b. Now we know what is sine pi minus b. That's simply going to be sine of the angle b, and it's going to stay positive because pi minus b means we are in the second quadrant where the sine function remains positive. In other words, what we can do here is we can say that sine of the angle a plus c, this is the same as sine of the angle b, provided a plus b plus c equals to pi radians. So that means for sine of a plus c, we can replace it with sine of angle b, multiplied to cosine of angle, we're going to keep it as it is, a minus c. Fine. Now reason why we converted sine of a plus c to sine of b, because we have sine of 2b. So here we can apply the formula. That means whenever we have sine of 2 times the angle theta, this can be expanded and written as 2 times the product of sine theta times cosine theta. For our case, since we have sine of 2b, this can be expanded to get 2 times sine of angle b multiplied to cosine of the angle b. So here what we can do, we can take sine of b as the common factor from both of the two terms. That will going to give us 2 times sine of the angle b. So we are just going to get multiplied to cosine of the angle a minus c minus cosine of the angle b. Now the advantage of taking expanding sine of 2b led us to take 2 sine b as the common factor, and here we can say that there is a factor sine b on the right hand side. So this is going to help us. So we now keep 2 times sine b as it is. Now what we'll do, we're going to keep the first term as it is. We have cosine of angle a minus c, but we are going to change cosine of b. So here again we're going to use the condition that a plus b plus c equals to pi. So let's use that. So we have since a plus b plus c, that's equals to pi radians, we're going to keep b on the left hand side and transpose a and c to the right hand side and rewrite it as pi minus a plus c. Now what we'll do, we're going to take cosine on both sides so that we get cosine of the angle B. So cosine of angle B is going to be equals to cosine of the angle pi minus A plus C. Okay, now what is cosine of pi minus some angle theta? That's simply going to give us negative cosine of that angle theta. Now theta here is A plus C, and we're getting a negative sign here because pi minus some angle, where the angle is A plus C, simply means that we are in the second quadrant, and in the second quadrant the cosine function is always negative. So a negative cosine B can be replaced with positive cosine of the angle A plus C. The intention here is we wanted to make the angle, since we have A minus C, so here we replace B with A plus C. Okay, now what we will do, we're going to combine these two cosine functions. Again, we can use the formula that if we have cosine of some angle C added to cosine of another angle D, then this is simply going to be 2 times the product of two cosine functions. And the sum of two cosine function gives us the product of two cosine functions. So the product is given by cosine of the angle C plus D over 2 multiplied to cosine of the angle C minus D over 2. So in our case, we will consider C to be equivalent to A plus C and D to be equivalent to A plus C. Okay, so this is going to be equals to 2 times sine of the angle B multiplied to, so we will need to factor 2, so we have 2 times cosine of, we have C plus D over 2. So C plus D means A minus C added to A plus C, so that's going to give us 2 times A, but we again have division by 2, but let's write it down. So we have 2A over 2 multiplied to cosine of angle. Next we need C minus D over 2, so C minus D simply means A minus C, and from here we subtract A plus C. That's going to give us negative 2C divided by 2. So we have 2 and 2 gets multiplied to give us 4. 4 times sine of the angle B multiplied to cosine of, we have 2A over 2, that's simply going to be A multiplied to cosine of negative C. Now luckily for us, cosine is an even function, meaning if we have cosine of angle theta, this is also the same as cosine of theta. So finally we have 4 times cosine of angle A multiplied to sine of angle B times the cosine of negative C can be also expressed as cosine of positive C, and this is exactly the expression on the right hand side. So let's verify. So cosine A sine B, cosine C, cosine A sine B, cosine C. So here what we have shown, that hence we have successfully showed that the left hand side equals the right hand side. Hence